Hey, how's it going? Sorry we had a little bit of technical difficulties getting started here with the stream, but I think we're good now. So we're going to go ahead and jump into our content for the day. So today we're doing a stream where we're going to be looking at making a game, a simple game, a simple mouse game. So far I have this mouse theme going on here, and I decided that I wanted to put some of the skills that I've been learning to practical use. Of course, guide it with a little bit of setup that I've already done before this stream. And yeah, it should be simple. So before we jump into this, just a couple of things that might have changed since last time. If you go down to the description, I added a new piece of reference resource content. In fact, I'll just show you here. This book I've really found super helpful. I've been using this in the stream, but if you're looking for like a really great solid resource, I think that this is probably one of the best resources that I've come across. And it's like super friendly and easy to read. It's called the GoLang book. And this book is available for free to the public from the author. So go down there and check that out. And then the other thing is, like always, I will have a repo on GitHub that you can use to follow along with this stream. In hindsight, if you'd like to, if you go to the link in the description below, you'll see that there is this repo here where I basically have set up all of the information about the game that I'm going to be making today. And then at the end of this stream, I will go ahead and push this up so that you can see this code and run it on your computer. Of course, you'll need GoLang installed for that to work. So yeah, that's my little preface. That's my setup. I don't know how long I'm going to work on this, and hopefully we can get this done. I have a really solid idea of what I'm going to do. Actually, I actually have the code for this already kind of pre-made. So the main goal with working through this in the stream today is just to go through that code, be really meticulous to make sure I understand everything, to use my reference resource here to like look up things as I go, and to write decent comments to document all the functionality. With the goal that I can walk away from this project with a clear example of how the fundamentals of GoLang are used in a working situation and in context. So this is kind of like a backwards way to study. This is equivalent to perhaps going on GitHub, finding a project that someone has done, and then spending time parsing it, except I am aided by some artificial intelligence that helped me design this game. So it's like it's a study method. And the reason why I'm doing this is because what I'm hoping is that after I go through this exercise, I will walk away with some useful patterns and also some useful code snippets for things that I have been really intentional to include in this. And then I can start to leverage this as a bridge to start making my own projects after this. So that being said, that's my preface. We can go ahead and jump into this. If you look at the README, Command Shift V to open up the preview mode here. We're making a mouse game. The mouse game is a simple console-based game written in Go. In this game, players navigate a mouse through a maze to find cheese, to find le fromage, to find le good cheese. Let's just take a moment to enjoy the beauty of Mr. Cheddar. This guy right here really, is kind of my life inspiration at this point. So it's really a homage to this dude here. Mr. Cheddar is the first AI meme, as I understand at least. So we're going to make the cheese game. Players navigate a mouse through the maze to find the cheese. The game is played in the terminal and uses basic character representations for the mouse and the maze. For this game, there's no like real graphics. It's just going to be all letter or Unicode representations of like cheese and mouse. So it's going to be really simple. This game ends when you successfully guide the mouse to the cheese, and it's going to be just a text-based maze. The features are simple maze structure, console-based interface, keyboard input, so you actually have to type in a character and press enter. And then what I think is really cool is that every time the maze renders on the screen, I clear the screen so it looks like a persistent screen as opposed to stacked consoles. And that'll make sense when I get to that part. So, so yeah, just read through this whenever you get a chance if you want to run through this. And the main thing is if you want to run this, then just use this command here. So that being said, I think we can actually start to work through this. And the challenge for me is going to be how do I organize this pre-made code in a way that makes sense so I can understand it as I do it. So fun, fun, fun. Okay, so one thing we always need is we need to have a main method, and this main method is going to be responsible for being the entry point for the game. Is the main entry point for the game to run when the terminal command is executed. And that terminal command is go run period. Okay, so where should we start? Okay, let's start by setting up a maze layout. I think that's the first part because for us, one of the first goals here is going to be getting the maze onto the screen, and then I can work on like all the other stuff. So yeah, let's go ahead and just make a maze structure. We're going to make a method that will actually provide us the maze structure. So method, or I'm sorry, a function that will return the maze structure. And this maze is going to require us to define a struct because this maze is going to be made of a slice of strings that represent each of the lines because this is text based. It's like ASCII art. So our function create maze, and the return is going to be of type maze. Let's make our type really quick. So type, what is that again? Type maze struct. This needs to be capitalized and represents the game maze. Okay, so this is going to have three properties. Or I'm sorry, three fields. So the first field is going to be grid. This is the actual maze. And this is going to be a slice of strings. So the actual grid itself. And no, I forgot this. And then it's going to have a width, and the width is going to be int. For this, it's going to be a 10 by 10 grid, but you know, I can make it larger, I suppose. And so width and height is going to be int and int. And then in this here, we will create. We'll have a simple maze or static maze layout, and we'll make a variable called layout, and this layout will be a maze, and the grid property here will be a slice of string, of course. And I actually have this grid layout here. I'm not going to pretend to just make this up. I don't want to sit here and type all this. So this is our grid. here. Okay, so, and we also need to have a width, of course, and we need to have a height. And width needs to be capitalized. And then we need to return the layout, of course, as well. And string needs to be lowercase. What's going on here? Oh, I did this in the wrong place. Oops, my bad. I did this in the main function. This needs to go here. Okay. And what is it saying? It's saying we're not using this. Okay, it's just unused. That's cool. Okay, so I think what we can do is we can just call create maze here. I just want to see this in the terminal. Let's go ahead and run our program. Oops. Oh, we gotta return. We have to actually print. We have to print that. So let's do fmt.print and then create maze.grid. There we go. Okay, that didn't turn out very good. I think I think I have here a way that this needs to actually be printed. Yeah, we're gonna have to print line by line, so we have to make a printer function for this. But the nice thing is that we can at least call this to get a maze, and then we can worry about the printing part later on. So let's just first initialize a new maze here, and we can do maze = create maze. And then we can work on having a printer later on. We can say print maze. Okay. Oh, I forgot to set a timer. Siri, set a timer for 30 minutes.
30 minutes.
Cool. Okay. So, let us go ahead and let's go ahead and make this printer. It's going to be a function called print maze, and this is going to have actually let me just try something really quick. Let me try something really quick. Print or fmt print maze.grid. Let's try something real quick. Nope. Okay, I thought that would do something else. Nope. So what we need to do is we need to basically take this grid, and since this grid is made of a slice of strings, we need to iterate through this slice and print each line. We need to print each line, and that will allow us to make this look pretty in the console. So let's just do that really quick. So we're going to pass in our maze to this function here, this print maze function, and then we can call that. And you know what I'm going to do? I think I'm just going to define these functions below main. I want to keep main at top. It just feels right. I don't I don't have like a good philosophy about how I organize my Go code, to be honest. Um, I'm just gonna sort of build from the top in a top-down stack. Okay, so func, or let's put a comment here. Function to print maze. These comments probably need to be updated at some point to be like more pretty, but this does it for now. Okay, so print func print maze, and then this will take in the incoming maze. I like to use INC because it helps me remember the difference. It also helps with conversationally, like talking about code as well. Um, so we take in the maze, and we need to give this a type of maze as well. And then, so what we're going to do is we're going to loop through each of the indexes in this slice. So for, and and since these are supposed to be like a grid, X is going to be the indexes inside of the string, or they're going to be the characters of the string, and Y is going to be the indexes of the slice, like XY coordinates, basically. Oh wait, you know what? I could probably use freeform to sketch this out. Let's try that. I actually have not used freeform yet, so this is a good chance to do that. Bear with me while I get my life together. Okay, so if I have this here, ooh, this is nice. This is very nice. How do I make this a different color? Oh, okay, just double click. Okay, so let me just make a bunch of these and make these different colors. Green. Okay, so I also need to have my little arrows here to indicate the directions. This is so much fun, by the way. I feel very happy right now. I'm trying to contain myself. Okay, so last thing here is this is like taking us back to like trigonometry. Okay, this is our x-axis, and this is our y-axis. On the y-axis, we have the on the y-axis we have the indexes of the slice, of the maze slice. Let's just do this. How do we write in our code? Make sure I get that right. Let's just say string. And then down here we have characters. We'll say char of string. So this is what we're working with. This is how we're going to basically treat our loop here, because we're going to have two loops. We're going to have one loop that handles the actual indexes of the slice for string. Then we're going to have a loop inside of that that handles dealing with the characters of each of these strings, basically. So yes. How do I save this? Okay. And maybe I'll go ahead and make this just a comment. This is how nested loops will generally work when you're dealing with a matrix. for a matrix. In this context, this is for a matrix of matrix made of an array of strings where the characters are treated as cells. But if you had like a array of arrays, like a two-dimensional array, it would be the same approach. So this would be how you do a for loop. So, oops, I messed that up. So if you were doing like a for loop, this would be like for loop and then for loop. Like nested. Let's put a tab here. So it'd be like for y, or let's say y is the index item. And then this inner loop would be for x index and then item. Like this. Let's make this lowercase. And then I'm not going to write out the whole thing, but hopefully this makes sense. This here is the for loop for navigating and exploring this type of data structure, regardless of whether it's all array data or all array sub data structures or it's an array of strings. They both will work the same. Strings are indexed or treated as indexed. So yes. Okay, so that's that. I'm glad I made this. Perhaps I will put this, I'll think about putting this in the notes, maybe towards the end. I'll see how I feel. Let's just call this a matrix diagram. Okay. Where do these save, by the way? When did I make this other stuff? Oh, these are from my coworkers. Oh, cool. Yeah, so yes, long story short, I don't be using this, but I should probably start using this. Okay, so let's get back to this. This is going to be our data structure, and we're going to make a loop within a loop to deal with navigating through all of these characters for each of these strings in the slice of maze, or the slice of this grid. So for that to work, our outer y coordinate loop is going to be for y, and this is going to be a line within this slice, a line of text, and we'll say range of maze.grid. So this means we're looping through all of the lines in this grid here. And for each of these, we're going to next, oh, I gotta call this incoming maze. Okay, so when we do this, we will take these lines and then we'll loop over each of the characters, which is each character represents a position along the x coordinate. So for x character, for a range of line, so this is going to allow us to iterate through all of the characters in the line. And then for now, we're going to do fmt.print, and we're going to print the character. So this is going to allow us to go line by line and print the characters. And right now, it's probably going to complain because I'm not using these x and y coordinates. I'll have to come back to this. In fact, let's make a note here. Let's make a to-do. Add the logic for managing the position of the mouse in the grid which will be an if else. Because if you notice here, we have not put the mouse in here. We're going to programmatically put the mouse in here with this function at print time, but it won't be there at the creation of the grid. So let's just also add that here. The mouse will be added to the grid at print time. Yeah. Because then we can change the position of the mouse in order to make different levels if we wanted to. Okay, so oh, we can also determine where the mouse is and keep track of the mouse's coordinates, which is going to be helpful for figuring out if we beat the game or not. That's the other thing. Okay, so now that we have that working, we can go back to our main function, and we can make sure that this actually works by calling our print maze function here. And so let's just run this, I guess. Nope, that didn't do what I. What is this? What did I even do? What did I do? What did I do? What? 3535. What is all this? I have no clue what I just did. Oh, you know what I have to do? I think I have to do this. I'm not sure why, but this is what I'm missing. I'm gonna have to look that up. Okay, kind of what I wanted. Oh, you know what I need to do? I need to print a new line after every line comes out of here, or else it's going to do it all together. And I could probably do a escape character, but I think it'll be easier for me to do this fmt.print line like that. So let's try it one more time. Okay, cool. So let's clear so we can see this fresh. That's this right here is our little grid. So the mouse is going to basically be able to navigate through here, go down here, up over here, down here, and then get the cheese. I have not found a way to make this prettier, so I think our best bet is to probably do this in the terminal. So let's go ahead and cd into here, OpenPair, GoLang, cheese, game, and let's do go run period, and make this big and chunky. I have a function also that will let us clear the screen as well. This will probably help in the sense that every time this runs, I can make sure that my terminal is not stacking a bunch of mazes on top of one another, and it'll keep this looking nice. I'll do that later on. It'll matter more when we get to like the player inputs. So this is our grid for now. It's our little maze. I tried to figure out how to do this with emojis, and I could not get the spacing to like look good. Because apparently emojis take up a different spacing than just regular. Like regular characters have a uniform spacing and emojis don't. So, okay, so we got the print function working. We have a small to do next, and the small to do is going to be how we can make this print function actually put the mouse in this. Basically, we want to have an M in here to represent the mouse, but we want this printer to actually be responsible for that. So we're going to need some starting coordinates, and I happen to have that pre-figured out. So we need to make a mouse, and this mouse struct is going to be the place where this these coordinates are stored. So mouse represents the player character, coordinates. So type mouse struct, and we need an X and a Y, and these will be integers. And then we'll use that and we'll initialize a new mouse. So this will be mouse colon equals mouse, and then we'll do x1, y1. Did I do these? What am I doing wrong here? Oh, I always do this. I always make these parentheses. They should be curly braces. Okay, so we're going to have to pass this mouse into our printer, of course, which means we have to change the arguments here to be incoming mouse of type mouse. And then we're going to use that here. So we need to have a if-else condition here, and if we have okay, so basically as we print through the indexes and we print through the characters, we basically need to decide if at the time we're printing each one of these, if it matches the XY coordinates of our mouse here, then we need to replace the space with an M. And if it doesn't, then we will just do whatever is in here. If that makes sense. So as characters are printed, if the coordinate x, y matches mouse, then print M. So we'll do if mouse x equals x and mouse y equals y, and fmt print M. And this needs to be incoming mouse. Okay. Oh, you know what? I need to be consistent here. It's need to be lowercase. Okay. And I need to bring back my coordinates here in these for loops. So we do a y on the outer one and x. Okay, so, and then if it's not this, then we just need to do else print our character. So this should, the main difference here now is that we should actually see our mouse in this. Let me use my little shortcut here to format. And let's go ahead and clear this and run this again. And now we can see we have a mouse here, a little M. So then now this will, now the goal is to figure out how do we change the coordinates here? All right, really we're changing the coordinates on this mouse struct, which is going to change where it prints on this grid at print time. Let me change this comment. Will print mouse M based on the or to replace character at given coordinate. That's what we really want to do. Okay, so that will replace the mouse at a given coordinate. Okay, so we're getting somewhere. One thing I want to look up is, what does this do? String is a set of all 8-bit bytes conventionally, but not necessarily representing. So when I did this loop over the line, this string, it must have did something. Let me find a GoLang scratchpad, because I really feel like I need to see what that does to understand it. I don't want to gloss over that. Um, I believe you can go to GoLang, the official website, and I believe that there is a way to do GoLang in the browser. I'm pretty sure there is. I literally saw this earlier and I just can't even remember where I found it. It was like an official thing, I thought. Um, by the way, I'm still on my don't use ChatGPT. Oh, here it is. Is this it? Oh, yeah, this is it. Okay, so we have FMT here. We need to bring in the strings. No, we don't need strings. We just need to loop over. So let's make a little string here. My string, and we're going to make just a bunch of hash symbols here, and we're going to do for car, let's start for I car range my string print fmt.print car, and we don't need the index. More than one character in rune literal. That I don't know what I did here. Let me just help myself and just make a new file in my little project, little temporary file here. Let me just copy this in here. It'll be easier for me to figure out what's going on if I do it in here. So run go string print.go. Or I think my break must be coming up soon. Go run. More than one character and rune literal. Oh, this needs to be double quotes. I think that's why. Single quote is just for. Okay. Nope. Oh. There we go. Okay. So this looping over this string must be doing something. What if I didn't use hash symbols? Would that do something different? So this must be turning, well, what is an A gonna be turned into? 97? Unicode character 97. Huh. If a 97 is an A, then I might do a backflip. It is! Okay, so when you loop over, it will convert it into a Unicode character. Or wait, is it Unicode? Yeah, it'll convert it into a Unicode number representation of the character. Okay, that's good to know. Um, I'll write that here. When looping over a string, the characters are converted into Unicode numbers for Unicode numbers that represent the character. The string function will um, will turn them back into what do we call this? A glyph, the appropriate glyph. Glyph. We'll turn Unicode numbers back into the appropriate glyph. I hope I'm saying this the right way. Let's just call, they're called decimals because apparently there's octals as well. See, I don't know much about this stuff. Um, I should call these decimals because I feel like if I say number, it's going to conflate it with this thing over here, and these numbers are clearly different. So let's just say converted to Unicode decimals, and I'll put a link here as well. There you go. So when you come look at this, you can just take a look here. Okay, so that's cool. I'm glad I took a little moment to like understand that. I'm gonna delete this. I don't need this in my code. And it probably would have worked here, but I guess I'm just new enough to not realize that I should have done this, and that I also should have done a double quotes instead of single quotes. This probably would have worked just fine. Yeah, so that does work. Um, ooh, my timer. So if you want to use like the web-based Scratchpad for GoLang, go to go.dev and then go to the bottom of the page where it says try Go. This is okay. I would just say that it does not have code completion, and if you're new, that is like one of the barriers for playing around is code completion because that really does help a lot. So, but this is great if you just have like a little quick thing you want to like scratch out. Otherwise, you can just make a file. You can do your go run and give it the name of the file you want to run, and that's also fine too. Okay, so I'm going to take a quick, let's say 10-minute break, and then I'm going to come back to this. I think we're probably like halfway-ish, somewhere roundabouts there, done. So this might be like just an hour and a half stream or so. So, okay. Yes, give me just a little bit to drink my little drink here. You know, just take a moment to breathe, and then I'll be back in 10 minutes, and I'll catch you soon. Peace. Hey yo, hey yo, hey yo, hey yo. We are back in full effect and ready to continue working on this. Okay, so let's jump back in here and pick up where we left off. Okay, so the last thing that we did was we got the actual grid to print in my terminal, and we were able to get the mouse to show up here at the coordinates that we gave it when we created the struct here. So 1 1, which means the first index, so here, and the first character here. And this is based off of how indexes work. So 0 is the beginning of either. So 1 is going to be really the second. So here. We could change this just for proof of concept here, just to see this be in a different place. Now it's here versus here. So we want to do 1 1 because we want this to actually print in a place that is a space right now. And then we're going to actually add some functionality to move this mouse around. And when we do that, we're going to make sure that this mouse can only move to places that are empty spaces or the cheese. If the mouse moves to the place with the cheese, that means the game has won. If the mouse moves to the place where the space is, the mouse can go there. And if you try to move to a place where there is not a space, such as these places with the hash symbols, then the mouse cannot go to those places. So that's how our game is going to work, basically. Okay, so the next thing that we need to do is um we need to make it where the player can input some command, and then that command we're going to do something with it. um Actually, no. No, no, no. We're going to save that part for last because that's going to be assembling our game to actually work. We need to make one more component. Let's make a component that will handle our input, but we're not going to do anything with it quite yet. But we're gonna just set it up for later on. So this is like the last piece that we need to do before we can go back and work inside of the main function. So this will be a function to handle changing the mouse position in the grid. And this will take in a an input. So here, let's write another line of comment here. We'll take in an input of W, A, S, or D, which will correlate to moving in one of 4 directions. Okay, so function. My cat is literally roaring beneath me right now. If you hear a very gritty meow, it's my cat down there. I promise you, I am not frying bacon. I promise you, I'm not frying bacon secretly under my desk. Clue. Meow meow. Yeah, yeah, that's right. You're cute. Okay, so we're gonna call this function handle input. This is a handler, so in the event loop, this is the handler. I guess this is following an event state render loop, which is funny because this is literally what I taught my students on Monday. The events I taught them in the context of DOM manipulation, dominant manipulation data structures, but that's basically the same thing going on here. It's an event state render loop. So I have an event, which is this handler, which is initiated by a user input. I have the state, which is this maze here, and then also the mouse data structure. And then I have the rendering, which is the print maze function, which is going to Eventually, it's going to be called on a loop, which is going to happen every time a player inputs a new character. So, event state render loop. Okay, so this handle input function is going to take in 3 arguments. We have an input from the player. That's going to be a string. It's going to be WAS or D. Then we need to have, we're going to manipulate the mouse's position based off of this. Well, what we're going to do is we're actually going to manipulate we're going to use this mouse data structure here. And we're going to make a pointer that's going to manipulate the values that this data structure holds. And I think we have to use a pointer because, from my understanding, is that when we make a new mouse from this struct, this is immutable. In fact, let me run a quick experiment really quick and do mouse.x equals 2. Let's see if that actually will let us update that without throwing an error. Let me run over here. Can you do that? 3. Let's make that 3. Oh, you can't. Wait, it is mutable? Oh, so it is mutable. So structs are mutable. Okay. Well, in my example, I'm using a pointer. I'm not entirely sure why. So we'll have to explore that. I do want to understand why that might be the better choice. So to bring the mouse in here, we're going to make a new variable. We're going to call this incoming mouse, and this will be a pointer to the mouse data structure. So whatever mouse is coming in here, we're going to work with its place in memory as opposed to the variable namespace. I'm still fuzzy on pointers, by the way. And then we're going to use maze, which is a type maze. Okay, so we need to have a switch, and we're going to look at the input to determine which case to do. So we have the first case, which is if it's a W. We have the second case, which if it's a A. These are just the typical navigation keys that people use for like video games when you play on a keyboard. We're moving forward, back, and side to side. When I do my cases, I like to just go ahead and write all of them out and then fill in the inner details with comments and then code. I feel like that helps me. Okay, so let's write comments for each of these first before we write code, just to make it really easy. So this first one, if it's a W, W is up. So this will move mouse up. And up in the context of our grid means we're going to do Okay, so up means that we're going to keep the same X. And here, we'll just do this. Mouse up means X equals X. And Y equals Y minus 1. There we go. So Y equals Y minus 1 means going from one line to the line above. And then X equals X means that when we press the W, we're not moving side to side at all. So it's going to stay the same. Okay, so when we push the A, that move the mouse left, which means X equals X minus 1. and y equals y. When we do s, s is down, which means that x equals x and y equals y plus 1. And then D is move mouse right. And that's x equals x plus 1 and y equals y. Okay. The other thing we need to do is for each, can I not put a comment there? I guess it doesn't like that. We need to do something in each of these cases too. For each case, check if the new position is empty or C. If not, then do not move. Or let's rephrase this. Only move the mouse if the new position is a space or a C. Only move mouse if target space is, yeah. Let's make these single quotes actually. Looks nicer. Okay, so let's just do this first one and then we can kind of take this and gleam off of it for the other ones. Also, I feel like I should be able to put my comments in here. Okay, I don't know why it didn't work at first. That was kind of weird. Okay. This is probably complaining because we're not using the function yet. Yeah, that's why. Okay, so we're good. I was tripping. Sometimes I'd be tripping. Okay, so if maze.grid, and then we want to check, let's check we're going to use the position of the mouse, and we're going to check up and see what's up. So mouse dot y minus 1, and then the x is going to be the same, of course. So mouse dot x. So this is going to be someplace on the grid that is at the same x coordinate but is minus 1 y, so 1 up. So on the first, if we're starting, oh, this is not going to work with my function not being finished. I wish I didn't clear it. Here, let me comment this out so I can print this real quick. Okay, so if we are starting here, this is going to keep the same x location, but it's going to look up. And if this is empty, then it's going to do the stuff. So we need to put x equals empty space. And also we could move if the space above is a C, because C stands for cheese. So we can just copy this right here and then do C. So if it is a C, then we are Gucci. What is this complaining about? Oh, we need to have this. So for now, we're just going to do fmt.print. Yay, can move. By the way, I'm still like freaking out that a single character in GoLang is called a rune. Like, what? I kind of like it, but not because it makes sense to me. I just like the way it sounds. Okay, so we're gonna just try this out. Actually, we can't do this yet because we haven't set up the user input portion of this. We can call the function and we can just force it without the actual user input. Yeah, we can do that here. So we could say handle input, and we need to give it a input. Let's just give it an input of W, since that's what we're doing right now. And we need to give it a mouse, and we need to give it a maze. It doesn't like that. Oh, I need to give it a address to. Okay, so the and in front of a variable is the address of that variable in memory, and I need to have that to correspond with this pointer. Okay, so when I run this code right now, it's going to automatically assume that I have moved it up one. At least it'll check. And what I'm expecting it to give me is it's not going to do anything, in fact. Um, so let's run this. Okay, I don't see anything. Now, if I start the mouse one space down, so let me change the y coordinate to 2. That'll put it in this space right here, which will allow it to move up. So let's run it again. And I can see here that I got my message. Yay, it can move. Now, it didn't actually move because we haven't done the logic to make it move. So let's do that real quick. So that will be, since we learned earlier that we can actually mutate a struct that already exists, we do mouse.y minus minus. This will, oh, incoming mouse. I keep forgetting to do that. It's crazy because like I literally do incoming as like the name of things a lot, but I'm forgetting tonight. So okay, so what this will do is right now my code originally will generate the mouse being in the empty space below here, but we'll actually see this console log here, yay it can move, and we'll see it in the position of 1 1 instead of 1 2. That did not work. Okay, let's see why. Incoming mouse is y minus minus. Oh, we didn't see the console log. Okay, that makes sense. Let me clear this because I removed the console log. Um, oh, you want to know what? The reason why we're not seeing it is because we have to call print maze again. Yep. Okay, let's do it. Okay, so we can see here it was here. Let me clear it so it's easier for you to see. So you can see it was here originally, and then it got moved back here. Cool. Okay. I'm so excited. This is awesome. Okay, now we have to do the rest of these. Since I already wrote out my little formulas here, I can make this really easy on myself and literally just do this and then just change these. So for the second one, y is going to be the same, x is going to be minus 1. And then put some space in here. Y is going to be the same, x is x minus 1. And then this will be x minus minus. And then this one here will be x will be the same. This will be y plus 1. and then this will be y plus plus. And then this last one will be um, x plus 1, x plus 1, x plus plus. And now we need to test these out. So we know that the W key works to move it up. Let's try down. So that will be the S key. And let's clear this and run our code. It should be down. So it was here, and now it's even down further. I can try the D, which is going to I need to change this back to 1 because it wouldn't work here, but it's going to start here, and then in the second frame we're going to see it in this space here. So it's going to move to the right one. Let's clear this. Oh, I gotta change this to D. My bad. Okay, so it was here, and now we've moved it one space over. And then in order to do the last one, I have to actually start it I have to start it here so I can see it move to the left, and left is going to be A. So it's going to go from here back to the space 1, basically. So boom, cat. Okay, so then the last thing here is, oh, we already did it. So if it somehow ends up in this position right here, it can still be rendered where the cheese is. And eventually when it gets to the same position as the cheese, which we will know based on the looping behavior, then that will signify that our game is done, that the game has been wanted. It's been want. So we are done with the basic elements of our game. Now we need to create the gameplay loop that will make this interactive. Yes, we need to make the gameplay loop that will make this interactive. And that's going to replace this here. It's so late. Okay, so this is the main gameplay loop. It's so late. It's like 2:17, and this is admittedly like way later than I should be up. But at the same time, I woke up. I came home. I went to bed basically after like watching a little bit of TV after work because I was really tired. And then I woke up at like 11. So I figured if I'm up late, it's fine. What matters to me is that I'm getting the quantity of sleep, not necessarily when I get that sleep. It's just I have just accepted that my sleep cycle sometimes gets a little bit dysregulated, and but that's okay as long as I'm getting my sleep and I'm eating and I'm getting like my other things in life together. The sleep is better to me for me to be flexible with it than to be like super. I have to bring in a new import that well, we have a lot of imports actually. Um, we need to first bring in an import that will allow us to read input from the player in the terminal. And this input is going to allow us to control calling the function for handling input, the thing we just wrote basically. So, and I don't know what all this does, so we're going to have to look this up as we go. So the first thing is I have to set up a reader. And this is going to come from buffio.new reader. And we have to pass in os.standard into it. And I don't know what either of these do, so we have to make some comments here to explain that. So Buffio, what is Buffio? Well, I've learned better than to ask what a package is because that's too big for right now. Let's just look at what new reader is. So that also doesn't help. Okay, let's go look at something else. Dang, medium. Okay, Buffio helps with buffer IO. Do a bunch of examples. We'll get familiar with these. It provides reader writer scanner. And we're using new reader. Let's go ahead and zoom down here. I guess this is just responsible for handling input output. I'm not sure why I'm uncomfortable with just accepting it as it is. Like I just feel like I need more. Um, okay, this seems nice. What is this website? Because I feel like I keep finding this. This is GoLang Is this in my README? I need to add this to my README. Let me add this real quick because I do keep coming to this website and I keep sleeping on it and I don't know why because this website actually is pretty good and I've found it helpful in this exact stream a lot. Um, GoLang docs and I do have Copilot enabled for Markdown. By the way, let me just take this link here. Yeah, let's use that. Cool. Yeah, let's add that. And I will add it to the stream. I'll try to remember at least later on. So, Buffio package provides a buffered IO in GoLang. I feel like the term buffered for me is also fuzzy. Like I see it, but I always kind of gloss over it. What does buffered mean? Come on, DuckDuckGo, help me out. Oh, I like this. So imagine that you are eating a candy out of a bowl. Take one piece regularly, and to prevent the bowl from running out, someone might refill the bowl before it gets empty, so that when you take another piece, there's candy in the bowl. So the bowl acts as a buffer between you and where'd it go? Between you and the candy bag. Okay, cool. So it's like an intermediate place for things to be held today. Yeah, it's a temporary place to store something in order to mitigate differences between input speed and output speed. While the producer is being faster than the consumer, the producer might continue to store more input in the buffer. When the computer gets around to it, you can read from the buffer. The buffer is there in the middle to bridge the gap. Okay, that makes sense. I'm not sure how that fits into this exactly, but it makes sense. So it's just a place to temporarily store things. So that makes sense because we might need a place to temporarily store inputs before they get stored into variables. I could see how that might be a thing. It's okay. Yeah, that makes sense. That makes sense. Okay. So the I/O operation computer costs resources, especially system calls. So we need more to be more considerate when doing things like that. The right operation to a file, it's done correctly, will come with an overhead. Sufficient. Okay, so this thing might also be useful for like writing to files as well. But we don't need all of that. I think we can just look up new reader. This is the only place it's okay. Reads can be done in some way, same way buffer writes are done. The API is very similar. Here's a complete example. Okay, well, that didn't help too much. Um, okay, you know what? I think I have what I need though. I'm gonna work off an assumption until that assumption proves wrong, and then maybe I'll revisit it later on. So, so Buffio dot new reader will allow us a buffer to hold the user input, which is then stored in a variable. Buffalo. In my mind, when I read this word Buffio, I get the mental image of the Pokemon Bouffalant, which is the um, buffalo with the afro. Here, let's look that up. I think I'm spelling this wrong. Buffalant. This is what I think Buffio sounds like. My guy. My guy with the afro. You know what I'm saying? My guy. Okay. Sorry, I got a little excited there. Okay, so we got standard in. I don't know what. Okay, so this is probably what allows us to actually. So this is probably what allows us to actually take in standard in our open files pointing to the standard input and standard output and standard error file descriptors. Okay. I do not like the Go package or package.go.dev documentation at all. I don't like the way this stuff reads here. It's like it makes sense. This is probably generated from something, but it's like this is not made for human beings with eyeballs in their heads. SCD IN, no, which just says the same thing. Not helpful. Like, I mean, I could continue without knowing the details of this, but I feel like it's the point. So this obviously is just the pattern for reading from the user. I could probably get away with just knowing this pattern, which is sometimes the advice that I give my students. It's like you have the desire to like know all these things, but it may not always benefit you the way you think it is going to, especially when you're trying to learn a lot of stuff really quickly. Okay, so it's going to tell me here, I think. So I could do this without a buffer, apparently. I might try that. Here, let's do this. Let's make a quick little file where we take this code and run it and then play with it without the buffer. So user input.go. And I don't think it's going to let me run this file because it would conflict with this one. So let's just go ahead and comment all this out real quick. Okay, so we could do run go user input dot go. Oh, go run user dot go. Girl, I almost entered in my password when I saw. I was tripping for a second. I was like, "Why is that asking my username?" This is a security breach. You need my password next? You need my social security number? Why you ask all these personal questions? You can tell I'm a computer person. I be freaking out. I'm like, you ain't getting nothing from me. You're not getting my real details about nothing. Made or death. Okay. Okay. So cool. So it's basically, I think it's telling me that I could do this without a buffer. Maybe. I don't even know what I'm doing. I'm just trying this out. Nope. Okay, wait. Let's try it here. Okay, that did not work. I literally just hacking and slashing it. I don't know why I thought that would work. Um, how would you do a non-buffered user input? Maybe that's not a thing. Oh, you could do scan F. Okay. So if we run this. Yeah. So I think the difference is that like you could do this, but you would have to pass in a address memory address to a variable that you want this scanf to store the user input. But I think the main thing is that this would be less performant. Okay. Okay, that's fair. That's fair. That makes sense. So we don't want to do that though. Let me just make some updates to my notes here and then we can continue forth. So um this is more performance. The alternative is to use the, what's it called, scanf. Use scanf. Uh, so either one of these approaches technically could work, I guess. Now, I'm noticing that this Buffio new reader seems to be the preferred way to do this. I don't know the use. Oh, excuse me. I don't know the use case. Um, I don't know the use case or the explanation. So buffered IO has much better performance than non-buffered. The package wraps an IO reader or an IO writer object, creating another object reader or writer that also implements interface but provides buffering and some help for textual IO. Okay, fair enough. I think I understand enough to be satisfied for now. Okay, that was like one thing that was like very intimidating for me. Okay, so the next thing we need a loop that will not stop. Uh, well, wait. Yeah, we need a for loop. Is there a while loop in GoLang? Or let's just look up loops in GoLang. Where's my GoLang book here? Okay, yeah. We need a for loop that's going to keep going. I'm not sure that there is a while loop. Um, is there a while loop in GoLang? I've never tried to do one. Um, while true. So I think we can do this. What I was thinking was a while true loop because then that will keep going. And then we can just choose to break out of it with some logic once the character gets to the cheese. But here we can do this shorthand for. So there's a loop construct and see like languages that is while true loop, which is essentially an infinite for loop. So um, a loop that will an infinite loop to re infinite loop. And this infinite loop will do a couple of things. It will first print the maze. And this loop is basically, we can think about this as like different rounds. Each round, it will print the maze. It will ask player for input. And it will handle input. And evaluate if the cheese has been acquired by M by mouse. Those are the four things that this is going to do. It's also going to clear because as you'll see here in a little bit, we're going to actually clear the terminal, but that's a to-do. So we'll just make a to-do here for now and come back to this at the very end. Through the terminal. Oh, excuse me. I think I'll take a break here, probably in like another 15 minutes. Okay, so this needs to be a for loop, an infinite for loop. So for, and then curly brace. That's all we need. And I don't need this stuff below anymore. I'm just gonna comment it out. I might need it later on for something. Okay, so let's just call this. Actually, no, this one. Okay, so to print the maze, we already have the print maze function. We wrote that earlier, which is print maze, and then we give it the mouse. Um, After we print the maze, we need to print to ask the player for some input. So f and t dot print move WSD. Okay. Let's just take a look at that real quick. Oh, we gotta get rid of this user input file. It's preventing us from running our main function here. Oh, it doesn't like our unused imports. Let's fix that real quick. That's one thing that kind of annoys me, but I get it. But it just also annoys me. Okay, so I was gonna keep doing this. We're gonna add some logic that will make this. Um, Once we add the user input, it's literally just going to wait for the user input to do the next part of the loop. So it won't keep necessarily running automatically because that waiting for the user to give it something is going to control the flow here. So let's actually do that now. So the input is going to be, we have to pull this input from the I think we do this. Input underscore equals reader dot read string. So this reader here, um, there you go. So this here will be the part that will cause our code to pause and wait for the user to provide something. And I'm not sure why there's an escape in. Um, oh, so this will return including the delimiter. Okay. Okay. Um, let's just console log, or let's fmt print. Let's just print input to see what that is. So this is gonna cause, let's say, we'll pause loop until player provides input. And then you can see here we printed out A. Let's do it one more time. I'm just ending this game by doing Control C, by the way. Okay, so cool. So this will wait for user input. And then we will handle user input. And we can use that handle input function. And this is what it is right here. The thing that we wrote earlier to test it out, except for instead of giving it A all the time, we're just going to give it input. So this will basically mean that this function calls always after the player provides it, and then the loop will be reinitiated, and then it'll go and wait for the next user input. So clear. This will also cause the mouse to move. As we recall, this function here is actually going to work to move the mouse. So let us do that. So this should be pretty close. Should be pretty close to working. So we can move the mouse down with S, press enter. No, it didn't work. What did we not do? Okay, we didn't do something right. Oh, oh, that's right. Um, wait, something's happening here. Something's happening. Something's happening. My guide says that we need to wrap this input in a function called strings.trim space, but I'm not sure why. Um, oh, there's something before and after. Um, can we debug this? It's been a while since I've debugged. I'm scared. Hmm. Actually, I don't know how to debug in GoLang. Girl, bye. I ain't doing all that. Uh-uh. Okay. Oh gosh, let me go to this screen and enter my thing in real quick. You ain't about to see my character count. Um, okay, I think this might work. Let me. Okay, so it is going right now. Let's enter A. Wait, wait. I don't know what I'm doing. Wait, restart. I don't even know how this works, to be honest. I wonder if Quokka or something would work with this. I'm gonna have to look into this, honestly. This is something I should know how to do. Um, this is something I should know how to do, but I don't. What are you complaining about? Okay. Yeah. Yep. So we're just gonna not worry about it right now. Another way I can handle this is let me try to print input again. Dot fmt dot print line, and let's print input. Let's just see if we can get something here going. Here. And let's enter an A. Okay, so I think what's happening is that we're giving it a new line with the character, which is explaining this here. Let's do it without the new line here. Oh, excuse me. I think we have to give it something. That's the thing. Yeah, we have to give it a delimiter. So we're giving it a delimiter. Okay, so read string requires a delimiter, which in this case is just new line. Before we pass the input into the handle input, we have to trim, otherwise the key won't be otherwise the input won't be recognized by the switch. I think that's what matters here. So okay, that makes sense. So this will just get rid of the trailing or leading white spaces around. So if we run this again, we can get rid of our little print here. Run this again. And let's move it down with S. Now it's down. Let's move it back up with W. That worked. Let's move it to the right. It moved it. Let's move it left. Cool. So move it all the way right, all the way left. Okay, so the last thing we need to do is we need to evaluate to see if it actually is in the place where I don't think there's a way. Okay, I could actually make it where this handle input could end the game, but I would have to pass in a pointer to a address where we store the game's success. And if it is at all, that would make it more complicated. We'd have to check to see if the place it's moving is the C, and then if it is, then we would have to um, update some pointer, which could be used inside of the main function to trigger a break out of this for loop and also print a message. Um, but another way to do this for now is that I know that this C here is in the 0, 1, 2, 3, 4, 5, 6, 7, 8, the eighth row, and in the first column. So just based on that, because this is just one static level, I can just do an if condition for that. So if mouse dot x is in the if within its row it is the first column, and mouse dot y, which means that if it's in the eighth row, I'm sorry, the eighth index, then in that case we want to break, and also we want to print a message. Print. Okay. Yes. Cheese is located at position 1, 8. Okay. Okay, so I can play this game now. It should work. And whenever we get to the cheese position, we should see this console log and also this loop that keeps this function running. It will end, and which will basically end our process here. By the way, this main function is a go routine, so that doesn't help or anything, but I just had to say that out loud. Okay, so let's do this. Let's get some cheese. Down, oops, down, 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 right, right, up, 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 right, 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 down, 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 down. Let's try to go into a wall. It won't let us. Cool. And then, and we got the cheese. Cool. What I probably could have done is I probably could have, let's put a log here. That way we can keep track of like where the mouse is. This would be helpful for debugging. I really should have done this, but I was being a little lazy. So fmt.print line, and we could say current position. And let's make this a print format, and we can do x %d for digit, y %d for digit, and this will be mouse dot x and mouse dot y, like that. So let's run this again. Why is this doing the hash symbols? Um, oh, I know why. Because it's trying to put the line on the. Yeah, I need to do um, in. Let's try this again. Okay. Yep. So there's the current position one, x1, y1, and we can see here we're at position 1, 8. Cool. Okay. Um, just ignore me. You know what? It's almost 3 o'clock. I don't care. Okay, so okay, I promise. Here's the last thing. We need to make a function that will clear out this screen so that we don't get this stacking effect. We only will see one set of grid print stuff at a time. I'm going to call that function clear screen, and I've yet to write it. Um, Let me just add some spacing and stuff here to make this look a little better. Oh, excuse me. And let's put the current. Um, no, that's fine. We'll leave it there. Okay, so let's make the clear screen function, and we can get rid of this stuff. We don't need this stuff anymore. So, function to handle screen reloading, clearing, and reloading. Um, and this won't take anything, no arguments. Okay, so there is a dependency that we need, which is called um, exec. It comes from OS, so os/exec, and we also need to have runtime as well because runtime gives us access to the runtime. Um, let's keep this in alphabetical order. So we need these two things. So the first thing we need to do here is we need to have a pointer to the command prompt. We need to have a pointer to this thing, I believe. Anyways, I have var cmd pointer to exec.command. And wait, this is a oh. I got this all mixed up. No, what this will do, this allows us to programmatically issue a command to the terminal during the gameplay loop for clear. Yeah, that's what we're going to do. So this right here, this is a way to hold the command, basically. Yeah, this is a way to hold the command. And this command will go to the terminal. we can choose to run this command, I guess. It has this line, which I don't understand. If runtime, this is a part of this code where I'm just like, okay, I'm going to have to do some more with this because I don't understand. I think there's a difference in whether or not this app runs on a Windows or a Mac. That this code here is basically adapted for. So if it is a Windows, then command equals exec dot command. I'm not even going to French you. I'm literally just following the directions here. CLS. You don't know what this means. Don't have a window computer. Not going to bother. More importantly, I think is this here. So this runtime.goos, this will allow us to programmatically determine what the operating system is that this code is running on. So go operating system. And if it's Windows, then it's going to set this as the command. Otherwise, we'll do command equals exec dot command, and we can just type in the literal command here, clear. So this is saving us a manual step. And excuse me. So this command object is the thing that's responsible for holding our command, and also it's going to be the thing responsible for passing the command to the operating system standard output, which is effectively just this little thing here. But we have to store the operating system standard output inside of the command object in order to run it. So must before command is ran need to store the OS operating system standard output inside of the command object. And then to actually run command, is cmd.run. Okay, so this clear screen function should be done. Only way to know is to test it out. So we're going to do go run period, and we're going to move this. Oops. And what I'm expecting is that when I enter this first command to move it down, this is going to all re-render in more or less the same location. Yeah. Now, the only thing that's causing this to look weird is that I have some console logs for like a console log for the position, and it is clearing because this clear screen happens before the position is rendered, which is not really useful if I'm using that for like debugging. So I'm going to move that up here and then restart this game. Move it down. Nope, that didn't do anything. Oh, wait. Now, why is that not? Oh, I need to do it after the clear screen. Maybe here? I don't know. Yeah. Okay, let's go ahead and clear. Okay, let's try to run this again. Okay, so now we can move this down. I think we might be done with our maze game. And hey, it's time for the percolator. It's time for the percolator. Okay, I don't know the rules around copyright infringement, but that's all I'm going to give you from that performance. So just relax, relax. I need you to relax, calm down. Okay, so that pretty much that's it. That's all. That's it. I done did the thing. Yeah, our game works. Um, it is 3:06. This stream has been a little bit over 2 hours long, and I feel great. Now, I know that I didn't come up with this idea all myself. Um, but the point of this exercise was for me to understand and work on my ability to read code and to glean some ideas about how code can be written to make a fully functional piece of software, in this case, a little simple game. And then I can leverage this to make something else. So I think that's going to be my goal in my next stream is going to be to make my own little game, different rule set, but something like that. Actually, you know what? I have a project that I might be interested in remaking in GoLang. Actually, now that I think about it, because this same functionality is the same thing that I'm using for this little animation tool I made in Python. So yeah, maybe I'll do that. We'll see, because I feel like that could be a really smart thing to do. It's like taking something I've already made in another language and converting it into GoLang manually. Because you know I'm a glutton for punishment. Okay, so as we get ready to go, inspiring words. What do I got for you? What do I got for you? Money, 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 money. Validation. So, what I would tell you has been a big lesson for me is that when you are trying to do things in life, try to do things that have intrinsic value for you. Even if you're doing things that are intended to help other people, even if you're doing something for a job, even if you're doing something because it's what you think you should be doing, try to find the intrinsic value, because in order to be consistent as a person, in order to show up fully and consistently with the right attitude and the right motivation, you cannot get around the need for intrinsic value. And intrinsic value is deeper than the money you might get out of something, or the validation you might get out of people, or the reward you might get out of something. Intrinsic value is based on what truly matters to you, you know? So, in the hierarchy of all of that, for me personally, validation is very low. I'm a person who often will seek validation and approval from other people. I want to take a step back and really think about, like, what do I need in order to be successful, in order to do what I'm going to do, in order to have a sense of purpose in the world. The validation that others give me isn't as important as it might often feel. For me, the intrinsic worth or the value of something is that I get to feel a sense of accomplishment and contentment and growth, and that it brings me peace. And when I focus on that intrinsic value, as opposed to all the other stuff that people in the world try to sell me in order to motivate me, I find that I'm a lot more consistent and motivated to show up. And I don't know, that means a lot to me. I think when it comes to coding and career shifts and there's a lot of hype around this stuff, especially coding. Like, you go online and you find all this stuff like, oh, you can make six figures in 6 months, and you could be a 10x programmer and make a killer app that makes you millions of dollars. It's like, okay, that stuff's cool, and maybe it gets you respect and gets you treated a certain way by other people and all this other stuff. But like that stuff comes and goes. And if you're relying on that to get you through the learning curve, to get you through the grind, to get you through the struggle zone, it's going to fade. It's going to come and go and it's going to fade. And it might be able to get you there, but it's not going to get you there in a way that it's like sustainable and that breeds contentment on the inside. The only way you really get that is if you're pursuing things that have intrinsic value and worth to you. And those might be things that are intrinsically valuable to some people, but I would challenge that it probably isn't for most of us. So, do things that make you happy, do things that help you to grow as a person, do things that are fully and deeply resonant, you know? That's what draws me to code. I love coding. Coding to me is like not just a job, a profession I make, but it is a way that I entertain myself. It's something I do to fill the time when I'm bored. It's something I'm constantly thinking about because it fascinates me. I view it as a language art in a way. And if it wasn't for that, I would probably do something else. I'd probably still try to get my cheese or whatever, but I would find a way to get the cheese in a way that please. I try to make that rhyme. You get what I'm saying? So, yes, validation and being approved and being the smart person, being, able to get jobs and all that kind of stuff. We want those things, but don't rely on them to be the core motivating catalyst. Unless that stuff is intrinsically valuable to you at the core. And you have to know the difference between motivations that are just based on circumstance and pressure and anxiety versus motivations that are actually leading and drawing you towards peace and contentment and happiness. Ultimately, both are elements and factors in deciding how we live our lives, but they have very different outcomes and sentiments and influences on how we exist. So, that's my speech. Hopefully that makes sense. If it doesn't, then let's just chalk it up to the fact that it's 3:15. Either way, I'll catch you later. Thanks for watching the stream. And go check out the links below. Check out the link for the repo. Comment, like, subscribe. Do all of that, all them shenanigans that they say you should do. And I'll catch you next time, right here, different time,